to generate the control signals, we can generate the control signals in two ways. One is by using hardware, that is hardware. Using hardware, we can generate the control signal. And another one is using a microprogrammed control. Microprogrammed control in the sense using the software, we can generate the control signal. So we'll see one by one. First, we'll see how to generate a control signal using hardwired control. So as I said, the processor, it generates the control signal. For what purpose it is generating? So it generates to perform an operation. So how an operation is performed? In the yesterday's class, we have seen how to execute a single instruction. That is, we have seen load instruction and add instruction. So if you want to execute a load instruction, we have to follow some 5 steps. That is, first we have to fetch the load instruction from the memory, and then we have to store it in the IR. We have to decode it, and then we have to execute it. While executing, if it needs any data, we have to fetch it from the memory and we have to execute it. So we have some 5 steps of operation. So those 5 steps of operations will be carried out using a control signal. For doing all the 5 steps, we need this control signal. Okay, so as I said, there are 2 basic approaches, that is hardwired control and microprogrammed control. So as I said, instruction is executed in sequence of steps. In yesterday's class, we have seen load. Load itself needs 5 to 6 steps. Okay, so we have, in order to keep track of these steps, we need a step counter. Because it is a hardware, we need a step counter which keep track the execution of the instruction. So sequentially, one by one, the instructions will be executed. But in some situations, that is, if you are using some branch instruction, in that case, sequential execution of operation will not be happen. In that case, depending upon the branch condition, if it is yes, some part of program will be executed, and if it is no, some other part of program will be executed. So we'll be setting the program counter so that it will give the address of the next instruction to be executed in a manner that is the instructions will be executed in a sequential manner. Okay, one by one it will be executed. But if you are having a branch instruction, in that case, the program counter will have the address of the instruction, which depends upon the decision taken by that instruction. Okay. Also, not only that, some external signals will be affecting our sequential execution of the program. Also, some interrupt requests, they may also interrupt the normal execution, that is sequential execution of our instruction. So for that, we need a step counter to keep track of the progress of the instruction. So in a whole, we need the control signals. What it does is, the control signals will be generated based on these four concepts. That is, it depends upon the content of the step counter, and also it depends upon the instruction register, and also the result of the computation or a comparison or anything, and also the external input signal such as interrupt request. That is, the control signal will be generated based on these 4 inputs. This is a block diagram of how we are generating the control signal. See, at the center, we have a control signal generator. It only generates the control signal. See, here we have the control signals. The control signal is generated by the control signal generator. From where it is getting the input? It gets the input from the step counter, instruction decoder, external input, and conditional signals. See, the step counter, it will keep track of the steps. What are those steps? For load instruction itself, we have some 5 steps. For add instruction itself, we'll have five steps. So all the instructions we write in 5 steps. So when you are doing the first step, it represents T1. So usually the first step is fetching the instruction from the memory. So for that, the signal generated, that is T1, will be enabled. The step counter, it will enable T1. So if you are doing the next instruction, that is when you are placing the instruction in IR, that will be handled by T2. Like that, we have 5 things. We always will have 5 steps. And when the instruction is loaded in the instruction register, then only this instruction decoder, it will decode the instruction, and then it will provide the necessary signal to the control signal generator. That is, it will enable INS1, INS2 to INSM. We have, it will generate the signals, it depends upon the instruction. If it is a load instruction, it should load the data in some register or in some other registers. If it is an add instruction, it should contact with the ALU and it has to add. So depending upon that, the instruction signals will be generated. Not only that, it will get the input through the external input. If you are having an input statement like C in N like that, so the value of N will be provided by the keyboard, so that will be assigned to the that signal, that for that we have to respond. We have to provide the necessary signal for that also. And also the conditional signals in the sense interrupt signals. When you are getting any interrupt signal, that is also should be considered. So by considering all the inputs, that is from the step counter, from the instruction decoder, and also external interrupts and conditional signals, the control signal generator will generate the control signal. So this is hardwired control. So these are the things what I have said. That is a circuit. This circuitry says how to generate a control signal. And also, as I said, the instruction decoder, it interprets the opcode and addressing mode information in the instruction register, and it will set 1 to the corresponding INSI input. INSI input, that is, we have a set of INSI 1 to M. So depending upon the instruction, the signal one INSI 1 to I, any one will be enabled. It depends upon the instruction. It may be load, it may be add, or it may be store. Depending upon it, the INSI will be enabled. And during the clock cycle, one of the inputs, that is T1 to T5. As I said, we have 5 steps for each and every instruction. So depending upon the step, it will enable the 5 outputs, that is from T1 to T5 of the set counter, and it will be set to 1, which indicates the 5 steps, as I said. And then here the control signal generator, it is a combinational circuit, and it produces the necessary control signals by considering the input from the counter, that is step counter, and also the instruction decoder, and also the external inputs. Okay. So that is the hardwired control. So while generating the control signals, we have to consider the data path of the control signals. The data path is nothing but how the data travels between the memory and the processors. Okay. So here, when the data enters into a register, the register will be having outputs. So through the inputs, we can A and B are the outputs. Through the input RA, RB, RZ, RM, RY are all the registers, and these are the general purpose registers. Depending upon our need, we can make use of the registers. We have the input to the register and also the output points from the register. We can store the data into the register, and also we can retrieve the data from the register. So the instruction will be loaded in the instruction register, where the decoder, it will interpret it, and then the necessary action will be taken down. So the instruction will be in our memory, and we have to fetch the instruction from the memory, and then we have to put it in the instruction register. There it will be decoded and interpreted, and later it will be the corresponding action. That is, if it is a load, we have to load the data. If it is a store, we have to store it in the memory again. Those actions will be taken care. And for example, here we have taken the RF write signal. Write signal, it is set to 1. So write signal, in the sense, write signal will be always in the T5. T5, that is, T5 is the last step. So what will be the last step? Storing the data again in the memory. That is the last step. So it is a write signal. Okay, write signal in the, what is write? Write is storing the data into the memory. Okay, so in the step 5, we will be always storing the data into the memory. So we are having T5. T5 will be enabled. So while enabling this T5, we have to consider all the other units also, whether the write may be in a ALU, or it may be a load, or it may be in the memory. So we have to consider T5 dot ALU plus load plus. When you are using an immediate in your instruction, so what we have to do is that is the direct value, that is the immediate value should be used in the should be added along with the instruction, so that we get the address. So that is what we have seen in yesterday's class. That is index we have seen. So likewise, we have this immediate. And dealing with memory delay. So always, I said the memory will be very, very slow when compared to the processor. So always when you are going to store a data into the memory, or when you are going to fetch the data from the memory, we have to leave one clock pulse, extra clock pulse will be needed, because the memory and the processor speed will not be same. So in that case, in between the steps, we'll be having a signal called memory function to complete. We have to wait for that. MFC is a function which is used to say we have to wait for the memory function to complete. Okay, we'll have the steps memory read and memory write. Memory read is fetching the data from the memory, and memory write is storing the data into the memory. Always when you are doing memory operation, we have to wait for one clock pulse, because the speed varies. Okay, so for that we have to use MFC. We have to check MFC. What is MFC? MFC is memory function to complete. So when the memory function is completed, a signal will be provided, so that we'll be moving on to the next step. Or otherwise, we have a function, we have a signal called WMFC. WMFC says wait for memory function to complete. We have to wait for, that is, we are making the, saying the hardware units to wait. That is, a memory function has to complete. It has to wait for some time, and then it has to resume.